A modeling question, and this time we have a cubic function, which we can see because we have this power of 3 here. But all functions are exactly the same, and so the first way that we're going to start this is to graph it. So you can see here I've written 0.0045 x, so I've changed the variable to x as we have to with the calculator. So x minus 30 to the power 3 plus 0.1215 x minus, and that should be a 30, so I can insert a 0 there. So x minus 30 squared. And then at the end there, I have 0.3585 x plus 23. So I can now move forward to graphing that function. Now, obviously at the moment, that doesn't look like I'm looking at the whole picture. That looks kind of like a linear line, and I can see that that's not a linear equation. So my advice would be, let's zoom out and see what we're looking at here. Now, if we're talking about salaries, we probably want quite large values. So maybe we should try, so it says here, when was his salary greater than 35,000? Now it is in thousands of francs, so that would be 35 on the x-axis, but we can see, on the y-axis, but we can see we're definitely not going high enough. So let's try 50. We shouldn't need a negative because ideally his salary would never be a negative value. His time will never go negative, so we could leave that as quite small. But if he's been working at the company a while, maybe we want 50 years there that he's been working. And now we can see a much better visualization of that graph. So the first thing that I'm actually going to do, I know it doesn't ask for it, but I'm just going to draw a sketch of that function. So it starts up here and we have this kind of cubic shape, and I just want to find out where does it start, and it starts there at 10.85. So here is 10.85. I know it's not asked for this information, but I think it's going to be useful for us for the question. So we could also find the maximum point and the minimum point. So the minimum is somewhere between here and here. So that is 28.37. And I'm just going to make this more accurate than 3 significant figures for now, because I don't know what I'm going to use it for later. And then it's 33.47. And the maximum point up here so I have this point here and this point here. So this is 13.621 and 40.705. So as I say, they're not rounded properly, they're just rough values that I can then use in my question. And I don't even need to label that part A because it's not needed. So part A is to determine the starting salary. So the starting salary is when his time, this is the time function, so the time versus his pay is when time is equal to 0. And at that point, it's 10.85, which means that he earns 10,850 Swiss francs. Oops, there we go. Oops. Swiss francs. And that would be his starting salary. Please don't leave it as 10.85 because it does tell us in the question that it's in thousands of Swiss francs. And then for part B, this asks us to find the maximum salary over the course of his career. So he tells us that he works for 40 years and then retires at the age of 60. So if he's working for 40 years, that means that our graph goes as far as 40 in the time. So this is when he starts work and then he works for 40 years. So his maximum is probably going to be the value when he hits 40. We can check if it's above that maximum here, but I would anticipate that it would be looking at this. So I'm first of all just going to increase my y-axis a little bit so that I can see a little bit higher. And let's find the value when he's 40 years old. And we can see there that it's 53.99, which is obviously much bigger than my maximum point. So it would make sense that his highest salary was probably the last year if he's increasing every year. So to find the maximum salary, it's when the time is equal to 40 because he's worked for 40 years. And therefore the value is, if I read that off, 53.99. So that is 54.0 to 3 significant figures, which is 54,000 Swiss francs. And then for part C, we're asked what times was his salary greater than 35,000. So that means when was it above 35, okay, which looks to be slightly above that minimum point there, which is 33. So I'm going to go to my graph and I'm going to add on 35. And I can see it's above 35 here and then again here. So I need to find all of those intersections to find where it would be. So the first intersection is at 6.98. So here is 6.98 on the x-axis. We know that the y-axis would just be 35. And I need to find the next one. So I'm going to find the intersection over on this side as well. And that's 24. So there's one here at 24. And there's also another one at the end there. So somewhere here, which is at 32. So there's also one here, which is at 32.35. So I have these different points. So when is he earning above? He's earning above 35 for this time and also for this time. So that means that it is between, or when time, is between, and we did these in the class where we have the greater than, less than symbols, 6.98 and 24.0. And it's when the time is above or equal to 32. Okay, so this is when it only asks for greater than. So we should get rid of these symbols here because that's when it's equal to rather than just greater than. So that would be my answer. You can also just write that in words. So you can say that it's between 6.98 years of working there and 24 years of working there, and then it's bigger than 32 years of working there. You can also convert that to an age. So his age would then be 27 because he starts working when he's 27. So this would be 27. Rounded up to 44, and then you could say that this is when he's greater than 52 as well. So you can convert it to his age if you prefer. And then for part D, the last part, what fraction of Manu's career was their salary increasing? It is increasing for all of these different values where we are increasing, so here and again here. Okay, so it's increasing for this part of the function, and then it's also increasing for this part of the function. So that means it's from when he started up until his maximum point, and then from his minimum point until he retires. So his salary is increasing between time is 0, or if we write it down as a inequality again. So it's increasing between 0 when he starts and the maximum point, which is at 13.6 to 3 significant figures. And then it's also increasing when he is more than the minimum point here, so 28 28.4. So all those different times is when it's increasing for his salary. And it asks for what fraction of his career. So that means that it's for 13 years here, or 13.6 years. And it's for when he's bigger than, when time is greater than 28.4. He only works until he's 40. So 40 minus that 28.4 gives me 11.6. So in total, he's increasing his salary for 11.6 plus the 13.6 years. Plus the 13.6 years. So that's 25.2 years in total. So 25.2 out of the 40 year that he worked in total. So it's this divided by 40. And we can see there that it's 0.63. That's how much of his career he's been increasing for. So 63/100ths. So in terms of the marks for this question, there is 1 mark for some sort of working and then 1 mark for the answer for part A. Then for part B, you needed to calculate his maximum salary. So again, there's some part of working and then an answer mark, and that working can look different for different people. For part C, there's 2 marks, 1 for this part and 1 for this part, and you can leave it as a time or as an age. And then for the last part, again, it's 2 marks, and for this one you can have the total of 25.2 is one of the marks, and then for writing it as a fraction.